Welcome back to Supply Chain Management. In this chapter, we're looking at static forecasting. And when we talk about static, we are under the assumption that new information, new demand data does not necessarily change the trend, seasonality, and level values. So remember, when we did the forecasting, we talked about three different kinds of ways you can calculate a forecast. You can do the additive method where you add the level, trend, and seasonal factor. You could look at the multiplicative method, which is multiplying the level, trend, and seasonal factor. But in this chapter and this class, we are going to look at mixed methods, which are the most common, where level and trend are additive and seasonal factor is multiplicative. So we are using the mixed model, and I'm going to go through some terminology here. F is your forecast at time period. This is the script here, T plus L, where T is time period T, and L is the number of time periods from which you have any data, and we'll talk about that. L is the estimate of level. Capital T is the estimate of trend, and this is your seasonal factor. And DT is actually your actual demand. So the formula for deseasonalized demand, where the first step which you do in any kind of static method, is essentially this very complex formula. And essentially what I want you to understand from this mess is that there's a separate formula when you have even number of seasons and a separate one when you have odd number of seasons. So that's all I want you to take off. Don't worry about this formula. We're going to skip this formula, and I'm going to show you what this very complex formula actually does through talking you through English. So when you're in Excel, to apply that formula, follow the following steps. First, you're going to find the average demand for the first year, and then enter it in the last season for first year, right? And you copy down that last group of data. And we'll walk through this in Excel also. We'll do this in Excel. Then you calculate deseasonalized demand, and instead of using that formula, you follow the steps. Now you have to look at the number of seasons you have. If you have odd number of seasons, then find the midpoint. For example, the midpoint of 1, 2, 3, 4, and 5 is 3. Midpoint of 1 to 9 is, I would say that would be 4. No, that would be 5. Yeah, 5, the middle number, right? Then copy the first average demand using the equal to sign, and then copy down. So I'll talk about this. Now, if you have even number of seasons, then the midpoint for 1, 2, 3, 4 is between 2 and 3, and that's 2.5. So we pick that, and then, so essentially what you're trying to find out is the median value. If you have odd number of values, the median is the middle number. If you have even number of values, the median is between the middle two numbers, and therefore you're taking the average of these two values. Once you do that, you have the deseasonalized demand, and then you run a regression to get the level and trend. And then you calculate the deseasonalized forecast, and then you divide the actual demand by deseasonalized forecast. You get the seasonal factor. You calculate the seasonal index, and then you calculate the forecast by multiplying the deseasonalized forecast and the seasonal index. So while these steps look confusing, we will follow them. So my suggestion is to print these steps out and keep a copy, or maybe take a screenshot of these steps. And then we're going to work on Excel with this data set. So here we have data which essentially talks about 4 years of data. Each time period is 4 months. So 1, 2, 3 is year 1, 4, 5, 6 is year 2, and so on. And we are asked a series of questions. First one is to plot the demand and show what it's like. The second one is to create a static forecast and optimize it. And then we are going to look at, I'm not going to do mean squared error. I think root mean squared error makes a lot more sense, and I'll talk about it while we are doing it. And we're also going to do some 95% confidence interval. So before we go, let's clean up the data. We have the time periods, we have years, we have seasons, and here's the demand. And let's go to Excel. The very first step in any forecasting problem is to visualize the data. So now that we have plotted the data, what do we do next? Now we're going to remember those 6 to 7 steps, which looked very complicated. We're going to follow those steps. So step 1, as I talked about, is to find the average for the entire year, for the first year. So we are going to take the average here of these 3 data points, and that'll give you the average demand for the first year. All right. Now, remember, if you have 4 seasons, you'll take the first 4 data points. If you have 12 seasons, which basically is each season is 1 month, then you'll take all the 12 data points and put the average right here, right? So don't just blindly copy what I'm doing. Try to understand what I'm doing, which is essentially saying, let's get the average for the first year. Now that you have the average for the first year, step 2 was go look at the number of seasons. Do you have odd number of seasons or even number of seasons? In this particular example, we have odd number of seasons. We will do another example which has even number of seasons, but this particular case, we have odd number of seasons, right? And so we have to look at the midpoint in this time period. So we have 1, 2, and 3. The midpoint of 1, 2, and 3 is 2. And so you're just going to select this and put equal to. You can copy this all the way down up to here, and you will copy this all the way down up to here, right? So this is the last one. If you copy it down further, you will get 0, and therefore you don't have data to do that, okay? So now that you have done this, this is your deseasonalized demand. This is your deseasonalized demand, right? And now that you've done this, let's go ahead and figure out what the regression equation is. That is, how can we predict this value from these time periods, okay? And what is this deseasonalized demand? We have essentially removed the seasonality, these up and down motion in a year, right? We have removed that from the data by averaging it and then using it as the median here. So those of you, if you click on data and you see data analysis here, you're fine. But if you don't see it in Excel, if you have a Windows-based Excel, I don't know how to do this in Mac. You've got to Google it and figure it out. But if you have a Windows-based Excel, you can go to File, you can go to Options, Add-ins, click Go, and make sure this Analysis Tool Pack is clicked. You click OK, and you go back and refresh your data. This should be right here, okay? So let's go to Analysis. We're going to look at Regression. And your input Y range, your Y range is what you're trying to predict. And here, this is F3 to F12. You just have data from F3 to F12. Your X range is what you are using to predict this deseasonalized demand. And it's not season, it's not year, it's time period. Now, do not click the entire time period. Just click the time periods for which there is data, deseasonalized demand data, which is time periods 2 to 11, all right? Since you have not selected labels, you don't have to do that. Since you don't have to worry about constant is 0. Your confidence interval is 95%, so you don't have to worry about that. I'm going to put this in a new worksheet, and then you have, don't worry about all these residuals and line fit plots and normal probability plots. If you do an analytics class, if you look at my analytics video, you have more on regression. But for the time being, in time series, you can just use this right now. So you click OK. And here you go, you have your data, and let's go ahead and get the formatted. So your multiple R is your correlation coefficient, and that basically tells you how strong the relationship is between time period and the deseasonalized demand. The closer it is to 100% or 1, the stronger it is. The closer it is to 0, the weaker it is. Now remember, this can be -1 or +1. Both of them are strong. And then here your R squared and adjusted R squared. Your R squared gives you the percentage of data. This 98.36% is, you can predict 98.36% of the change in deseasonalized demand just because of the change in time period, right? That's your R squared. You use adjusted R squared if you have more than one variable which you're using to predict your demand. And in this case, we are just using one variable. Your standard error is the average you're going to be off. The forecast is your average value, and this is the standard error. So now let's look at your significance. Your model is highly significant, which means that there is a strong chance that this is not just happening by random chance. Okay, and it's less than, if this value is less than 5%, you can start looking at these values here. Okay, so let's look at these values. I am going to go ahead and format it so that it looks nice. Let's use comma separators. Here we go, and the p-values here are percentages. So your intercept is 7,350 and your slope is 205. So I'm just going to go ahead and copy these two values. Here are your confidence intervals given by Excel here, right? So I'm going to copy these two values and put them right here. Your as intercept, and I'm going to call this slope. Okay, so you have the intercept and slope. Let me move these graphs down because we'll need that space. So here we have the intercept and slope, which is all ready. And now the next step, if you look at the sheet which I talked about, we have step number 4, where we are looking at level plus trend. We are looking at what would be the deseasonalized demand using this intercept and slope. So let's talk a little bit again of what this intercept and slope actually means. The intercept is essentially right here at the start, at time period 0, what is your demand going to be? And the slope is that with every increase in time period, your demand increases by this many units. So here we go. Let's go ahead and just format it. So we have the intercept and slope. Here we go. So this is going to be your level. This is essentially, your intercept is nothing but your level, and your slope is nothing but your trend. And make sure that you use the F4 button to get the dollar signs so that B17 will not change when you drag it down. We are going to multiply the trend with the time period, right? And here we go. So now that we have this, let's copy this down for each one of the time periods all the way up to 15. And you will see we have level B17 plus your trend, which is B18, multiplied by the time period 2, 3, and 4. Because, and let me change this intercept and slope to what it is, level and trend. Let's call it level and trend. This is the level and trend at time period 0. All right. So let's go ahead and get this all nicely formatted. This is something I actually tell everybody to do on a regular basis, because it's easier to read your Excel file if you actually format it. And now we're going to get the seasonal factor. So the seasonal factor is essentially the difference between your demand and this value here. So this is essentially level plus, whatever your trend is going to be. We're saying this is actually your deseasonalized demand based on the regression equation. And the reason why we are not getting 8,000, but we are getting this is because of the seasonal factor. So we take demand and we divide it by this value. Remember that the forecast is level plus trend multiplied by seasonality. And so when we divide this by this, we get the seasonal factor. So you get the seasonal factor and you can copy this all the way up to the point where you have data here. So this is a percentage value. And what you're saying is, hey, this here is about 105%, the demand, the seasonal factor is actually increasing the actual demand by an extra 5%. Here it's increasing it by 6%. You actually expect to get this if there was no seasonality, but it's actually a little bit more. And here it's about 6% less. So here we have seasonal factor for each time period. But the problem in having these seasonal factors for each time period is that they are different. We need one seasonal index for each season. So for season 1, which is here, here, and here, we need kind of one seasonal value. So we have 3 seasons here, and we are going to find the seasonal index. And essentially what I want is the average of this, and this value. These 4 values, I want the average. And you can do average of, you can select it individually. But the problem in selecting all this individually is if you have 300 data sets, this is 15 and it's a toy problem. But in reality, you'll have a big data set and you won't be able to manually and individually select it. So we use the average if function, and the average if function asks you first for your range. And the range you are looking at is essentially this. You're looking for these values. You want to use the function key F4 in your keyboard to make sure there are dollar signs. The criteria you're selecting is essentially this here. So is this season 1 or season 2? And you're not going to put an F4 here because when you copy it, you want this to change to A21. And if it's 1, then you want the average of these values. And again here, F4 comes into play. So you can see here for season 1, the average is about 102.51%. For season 2, it's 105, 5% more, and season 3 is 92. And I'm going to actually take the average of these seasonal indices. And the average of these seasonal indices is about 100.3%. And that's a problem, and we'll talk about it soon. Okay? We cannot have it at 100.3%. So let's go ahead and clean this up. All right, so we have the seasonal index, and now we have to figure out what your actual forecast is. And your forecast, this would be your FT, right? So your forecast is essentially, it's this value multiplied by whatever your seasonal index is for season 1, all right? And this value multiplied by your seasonal index for season 2, right? So you can do the first one and then copy 1, 2, 3, but then when you copy down to 4, there is no, that's wrong, right? It has to go back to 1. And again, so we need to figure out with Excel some way to automate it. So for that we're going to use a VLOOKUP. And VLOOKUP is looking for a lookup value. It is trying to look up this particular value, this season, from this table, you'll notice that I did not select the headings. It's just selected the seasons 1, 2, 3. You're going to use F4 to pin it down. And then you want this to return the seasonal index for the specific season. So if it's going to look up C2, which is season 1, you want it to return 102.51, and that's in column number 2. And here, range lookup is false here because we don't have a range of value. We have season 1, season 2, season 3, right? So you'll notice the answer comes out to 102.51%. So this is going to be your percentage value, and this value will be multiplied by your level plus trend. And so if you copy this down all the way, you will end up with your forecast, right? You get your forecast. So let's go ahead and copy this down, and you have your forecast. So here is your demand. Here is your demand, and I'm going to go ahead and add another set of data. I'm going to add, this is my forecast, and I'm going to show my forecast right here, and bingo, right? We have done this. We have got our forecast, all right? And our next step is to optimize this. This is still not good enough. So normally after this, we would calculate error, your squared error, absolute error, your percentage error, and then get the average mean squared error, the mean absolute deviation, and so on. But for this lecture, because we've already finished about 20 minutes, I'm just going to look at the absolute error, right? I'm going to calculate the absolute error, and then we are going to optimize this. So here is ABS, which gives you the absolute value, and forecast minus demand. And I'm going to copy this down. And so we have the absolute error here. And once we have the absolute error, the average of these values, and make sure that you don't select the blank values, the average of these values is your mean absolute deviation. This is your MAD, or mean absolute deviation, right? So we are saying, hey, your forecast, this is your forecast, and actually for year 5, here's your forecast, but you're about 125 units, 125.48 units off on average from this. But we can actually optimize this. So whatever we have in the sheet, we are going to run and copy this, and let's create a copy. And we have an optimized sheet here. And the first step for the optimized sheet is that you have to understand what it is that you are going to optimize. You are going to minimize the mean absolute deviation. This is what you're going to minimize, and such that you're going to change these values. Level, trend, here are the values that you're going to change. Level, trend, and your seasonal indices. You're going to change these values in the green so that this is as small as possible. Now for the computer to change these values here, these values cannot have formulas. These green values cannot have formulas. Right now you have formulas, so you're going to copy and you're going to paste values here, right? So none of them have the formula here. Also, the average of the seasonal index should be equal to 100, right? This should be equal to 100. And the reason is, if this is 100, then you can say this is 2.5% more than average, whereas this is about 8% less. So this has to be equal to 100. So if you go to data, and you should see solver here. If you don't see solver, go to file, go to options, add-ins, click go, and make sure the solver add-in is selected. And you click OK, you'll see solver appear here. And I'm going to show you two ways here. One is using this solver, and another one is using the software analytics solver. So if you don't have this software, which is a separate software that you need to get, you can use Excel's default software. So let's use Excel's default software. And so here, your objective is J17. And remember that you're trying to minimize this. You're trying to get the smallest values for this. Your changing cells are level and trend, and then use Control and select the 3 seasonal indices. And then your constraint is that this cell B23 is essentially equal to 1. And you click OK. Now, the solving method is nonlinear, so you can just keep it nonlinear, or you can use evolutionary, one of these two. You cannot use simplex. Okay, so it has to be either nonlinear or evolutionary, and you click solve. And then it'll converge. It says solver has converged to a current solution. All constraints are satisfied. You click OK, and you'll see here it has reduced the mean absolute deviation to 114. It's found some new level and trend values, and it's given you your seasonal index. Now, if you look at this here, your seasonal index, your first season is about 1.86 above average. Your second season, the demand is about 5.87% above average. And your third season is when your demand drops about 7.74% below average. Okay, so compared to the previous one, you definitely have a much smaller error right here. So now we are going to look at the static method, but for the even number of seasons. So remember, we did odd number of seasons before, and now we are going to work with even number of seasons. So let's take a look, and we'll see how we are going to do that. So let's take a look at this data. Again, we have the same set of data, but there's a difference here. Assume that each time period is 3 months of a year. So 1, 2, 3, 4 is year 1, 5, 6, 7, 8 is year 2, 9, 10, 11, 12 is year 3. And we are going to build a static forecast to optimize it for this, this data set. Now, here we have year 1, year 2, year 3, and we have 4 seasons instead of 3 seasons. Let's move on to Excel. So here we are in Excel with the data set we're given. Here is the demand data. Here are the seasons, and like every good forecaster, the first thing we do is to essentially get a scatter plot, right? But in this chapter here, right now in this lecture, because we've gone in such detail with the previous one, I'm just going to show you the difference of what you need to do with exponential smoothing. So the first step is to do it exactly like the previous one, where you go to the end of the first year. In this case, the first year is season 4 is the end, or time period 4, and you take the average. The next step is where it is different from when you have odd number of seasons. Remember, an odd number of seasons, you went to the midpoint and said equal to this value. Now when you have even number 4, you're going to take the average of these two, and then you're going to copy it down until you reach the last 2 data points. Now if you go down further, this would be wrong because you don't have a data point. So always check and make sure that you have stopped right here. Now this will change. If you have 12 seasons, you're going to have to do it carefully for the first 12 seasons, and you're going to start here, right? If you have 6 seasons, right, you're going to do it for 6 and then start here, and then look at the midpoint and take the average too. So I hope this is you got that. So now, just like you did the last one, you're going to take the regression of this and this value, so you get your intercept and slope, or your level and trend. And then you're going to calculate, once you get your level and trend, right? You do it exactly as we have done before. There is no difference here. Then you get your seasonal factor. Using the seasonal factor, you use average if to get your seasonal indices, and then you can calculate your forecast. Now, I've gone through this very quickly because we have already seen all the details when we did the odd number of seasons. So the only difference between even seasons and odd seasons is how you calculate your deseasonalized data. Now let's look at the optimization. I showed you one way using Excel's default solver, and now I'm going to use the analytics solver, which is a more professional version on how to optimize this information. Now the last part comes with optimization, just like we did the last time. So the first step to optimization is to copy and create a copy of the sheet. Instead of using data solver here, we're going to use the analytics solver that most of you in this class have, or if you don't have it, it's available in the lab. And you're going to select the objective. Objective here is your mean absolute deviation, right? And that is what we are going to minimize. So we're going to select this. We're going to say add objective, and we are going to minimize this. And remember that you're changing cells. All these cells have to be, can't be formulas, have to be numbers. So we are going to select these, copy the seasonal indices and paste values. Now under optimization, you can come to variables. You can select intercept and slope. Remember that the intercept and slope is level and trend. And here are the seasonal indices. And you're selecting them as variables. Remember that these should not have formulas. And remember that your constraint, just like you did, should be equal to 1, right? And you can go to engine, that you see the non-linear there, and you can run this. So it says that my variables contain formulas, so I need to check to see whether my variables have formulas. So let's take a look. Here are formulas. As you said, these should not be formulas, they should be numbers. So now they're numbers, and now I can run it and get a solution. So here we go. The seasons. First season is 3% above average. Second season is 5% above average. Third season is about 9.04% below average. And this is about 8.68% below average. So you have this entire thing optimized, and you will note that your MAD has gone down to 143, whereas in the previous example it was 165, and now it's 143. And of course your intercept and your seasonal indices have changed a bit.